Right, and welcome. This is our second video on graph sketching, and in this one we're going to be looking at reciprocals. The first video we were looking at quadratics, cubics, quartics. In this one we are going to be looking at the reciprocals in the form a over x and a over x squared, and go through the similar process to what we did in the last video. So, the reciprocal curve y equals 1 over x. Right, let's consider what's happening with the y-intercept. That's going to happen when x equals 0. So if we have a look at that equation, when y equals 1 over 0, and straight away we can see we've got a problem, because 1 over 0, yep, we can't do that. It's what we refer to as being undefined. It just doesn't exist. Some people will try and write that as infinity. It's not. It's not 0. It's not. It is undefined. There is no answer to the question, what do we get when you do 1 divided by 0? So what that means is that it doesn't go through the y-axis. Okay, so even on that means that the y-axis is what we refer to as being an asymptote. Slightly bizarre word, but it just means a line that our curve won't touch. Now, the thing we have to think about though is what's going to happen to that graph as it gets close to 0. So what we're saying there is as x tends to 0 from the positive side, that means x starts getting very, very small. And what happens is if you imagine if x is very, very small, if we had a value of x that was, I don't know, 0.000000001, something daft like that, then we've got 1 divided by 0.0000001, and that's going to be an absolutely huge number. So what we're saying is x tends to 0, y tends to infinity. It gets absolutely massive, and the curve just shoots off the top of the scale. Now, next thing, what happens, we've considered what happens if x is very, very small. What happens is x gets very, very large. So let's pick a massive value for x. Let's imagine x to be 1,000,000. Well, if x is 1,000,000, we've got 1,000,000 in here. All of a sudden we've got y equals 1 over 1,000,000, 1,000,000th. That's getting very, very small. And as we make x bigger and bigger, as x tends to infinity, y is going to tend to 0. So what that means as an intercept is, well, when y equals 0, we've got that, do a little bit of rearranging, take the x over, and all of a sudden you've got that. Again, which makes absolutely no sense. And what this is all telling us is that that curve will get very, very close to the x-axis, but will never actually touch the x-axis. So it turns out the x-axis is an asymptote as well. So if we just look at that kind of positive section of the curve, what we're going to get is a curve that just does that. Let's say it's kind of got that curve in that upper right quadrant, getting very close but not touching the y-axis, getting very close but not touching the x-axis. Now, exactly the same kind of principles happen for negative values of x. So if I'm putting in x values down here, and of course if x is negative, we've got 1 over a minus value, so that's going to be negative as well. So what happens is we've got exactly the same looking curve, but in that third quadrant there. So essentially our y equals 1 over x curve is in two completely separate sections with both axes acting as asymptotes. Now, if we consider y equals 1 over x squared, exactly the same thing is happening when x is 0. For the x-intercept, when y equals 0, we've got the same problem again, so exactly the same principles are happening. Those axes are asymptotes. And as x tends to 0, now I've put here x tends to 0 from the positive side, y is going to tend to positive infinity, because the whole thing is positive. But if x tends to 0 from the negative side, i.e. we're talking about very, very small but negative values of x, when you square a negative, it becomes a positive. So we've got y tending to positive infinity. So when x is positive, the y value disappears off the top of the graph. When x is negative, the y value disappears off the top of the graph. And that's because of the squaring. So what happens is, there's our y equals 1 over x. But in this case, what's happening is 1 over x squared looks like that. So just to tidy all that up, what we've got is our positive reciprocal, negative reciprocal, same shape, but the curve is appearing in the other two quadrants. And if we've got a constant here, so for example 2 over x or 3 over x, all that's happening effectively is the curve is being stretched away from the x-axis, so it just kind of looks like it moves further out. For the squared version, again, here's our positive version. The negative version, we just put a minus on the front of it, and everything flips and becomes negative. And the same structure again for our k over x squared.